Hello, welcome to Software Testing Methodology. So, today we are going to start Unit 5. So Unit 5 is State Graphs and Transition Testing. So there are two parts here also. One is state graphs and second part is graph matrices. The first topic in the state graph and transition testing is state graphs. So second topic is good and bad state graphs. So third topic is state testing. So fourth one is testability tips. So these are all the four topics in part 1 of Unit 5. So part 2 of Unit 5, graph matrices and its applications. So the first topic is the motivational overview, matrix of graph, relations, power of a matrix, node reduction algorithm and building tools. So these are all the two parts of Unit 5. First part is state graphs and transition testing. So before that, what is meant by state graph? What is meant by state testing? So before that, what is meant by a state? A state is nothing but its system's behavior. So what's the system's behavior? So if we take any process, if the process is in a ready state or run state or new state or it is in the interruption state, whatever, where the system process be, where the system function be, all can be defined state. So when the testing applies on particular state, it is known as a state testing. All the state testing can be defined based on the state graph. So that what is meant by state graph? The behavior of the system is represented in graphical form, which is known as a state graph. So whatever the graphical form we are defining, whatever the behavior of a system can be represented in a graphical form or in any diagrammatical representation, it is known as a state graph. The state graph is used for functional testing of the system to identify different bugs. So functional testing, mainly this state graph is used to define the functional testing of the system to identify different bugs, whatever the bugs rises in that. So to identify the state bugs, so what are the bugs like transition bugs, state bugs and transition bugs. So before that, what is meant by bug? So bug is nothing but a problem or error. So whenever those bugs are raised in the state testing, it is known as state bugs, and the bugs that are raising conversion of or transition of one state to the another state, from one state to the another state, it is known as a transition bug. So what are the elements using in the state graph or state graph? So first one is states, inputs, transitions and outputs. So first, what is meant by states? So a state in the state graph is a node which represents the characteristics and behavior of a system. State graph has set of states and they are identified characters or number. So this is the state. State is nothing but it is a characteristics and behavior of a system. When the system behavior changes, the state also will be changes. Whether if it is the process is in a system is in a new state, it is a new state. It is in a new. If the system is ready to function, it is in a ready state. So that is the state defines which character changes from time to time. So what are the inputs? Inputs is nothing but giving values to represent the changes to the state. Giving inputs, nothing but giving some variables or values to the particular state. They can be denoted by the number of characters in there. So transition means nothing but links joining two states. The link that joins two states is known as a transition. So from which state to the another state, what is the transition is going on between the state to state, all can be defined in the transition. The state changes in the process of changing of the state is known as transition. So next last one is fourth element is output. So what is meant by output? After processing an input, the result is produced. So which is known as the output. So after completion of everything, state or transition, defining the state or transition between the state to state, at the end of the stage, we'll get the output. This is nothing but a output element in the state graph. The input and output of the state graph are separated by slash. So see here example of state graph. So this is the state graph. We can call it as this is a state. So state, S means state, start state. So if we take any this is the best example for the states, which nothing but ATM transactions like entering PIN number, verifying that PIN number, entering some amount, all can be defined. This is the sum of the state. So see this state graph, example of state graph. So S means start state. S to 1 means A means what is the transition means entering PIN number, what the input we are giving. So 1 is nothing but a process. This is the state again. verification of PIN number. Next, 1 to C. C means PIN number is wrong, displayed to the customer. Again, the re-enter PIN. This is the another state. Again, PIN will be re-entered. Again, the state will be starting. Again, enter PIN number. So the PIN number is wrong. Again, same third state will be performed. So again, after verification of PIN number is done, it will go to the PIN number is okay. And 2, screen displays 2 options: balance inquiry, money withdrawal. So we'll go for balance inquiry chosen, and fifth state print receipt. And D, if money withdrawal is chosen, enter amount. Amount is entered. So amount is entered, received money, receipt is printed. So this is the states. So all these nodes or rounds is nothing, circle format is nothing but state, and link, this is arrow mark is transition. So this is the example of state graph. Next, what is meant by finite state machine in this? So finite state machine is a model of computation consisting of a set of sets: a start state, a input alphabet, and transition function that maps input symbols and current state to the next state. All these combinedly known as FSM, nothing but finite state machine. FSM can model a large number of problems such as design automation. If there is any automatic, design automation like any automobiles or any electronic devices need to be designed, this finite state machine models a large number of problems. It defines not a large number of bugs. Why? Because the coding will be defined, or coding don't need to be designed, or some of the architecture need to be designed. All can be defined in the design automation. Next, second one is the parsing. Parsing is a technique which defines way of parsing, like checking of those interpretations of sentences or languages, grammar, all can be defined as the parser. So nothing but third one is protocols, nothing but networks. So in the way of network, how the network is designed, protocol design, whatever is the software application, what is the protocol, what is the protocol of your software. So all can be in these three areas. The FSMA can be used to model a large number of problems. So next, another concept to define in this state testing means state table. What is meant by state table? It consists of, it is a form of table which represents the state graph. That whatever the graph consists of, everything, inputs, outputs, transitions, all can be defined in the state table. This is done because it would be difficult task to go through all the nodes of the state graph. So by seeing the state table, we can easily make a testable way to define the state testing. If the graph is converted into table, it would be more convenient. So the state table is also known as state transition table. So that this table consists of rows and columns based on that information. So what is meant by state graph means, we see here, this is also one of the example graph, like hard disk recovery. So see this is a start state, nothing but a state which defines. So if the good sector is performs, okay. If there is any bad sector, then go to another process. So bad sector will be repaired. So again in this state, the sector will be repaired, and again it will go to good sector. Again the checking will be done, testing will be done. If it is good sector, okay. Again it leads to the bad sector. Then again go to fourth state, like you said, bad sector, again repair. 2 times repair will be done. And after completion, again it will send to the starting state. Again still there is a repair operation. Then again same, it will go to the Q state, which performs the formatting. This is the formatting state. Still, if the format performs, if it is a good sector, then the starting state will be performed. Still, if you done the formatting also, there is no changes in that particular sector, then the damage, total that sector is damaged. So ending state will be performed. So this is the state graph for hard disk recovery. Next, coming to the state table. So state table consists of inputs, states, inputs, outputs, transitions, and outputs. So whatever the example we have taken, like hard disk recovery, so S, P, Q, or F, these are all the states. Good sector means no operation will be performed, all the sectors will be good. Bad sector means there are operations will be performed and states will be changes like repair, format, and damage. So this is the state table which consists of states, inputs, transitions, and outputs. So this is the state table which consists. So next, time versus sequence. How can we take the time? What is the based on the time? What is the based on the sequence? So state graph doesn't represent time; they represent sequence. A transition might take microseconds or centuries. A system could be in one of state of milliseconds and another for eons. Although the fine FSM model can be elaborated to include notions of time in addition to sequence. So we were comparing to the time versus sequence. So state graph doesn't represent time; it represents sequence. If the state graph consists of a sequence, then only all the states to be executed to be implemented in the successful way. So that's why it represents the sequence is the best way to define the state graphs and state tables. So next coming to the software implementation. How the software implementation done in the software testing. So the state graph is representation of behavior of overall system graphically. It represents each and every state transition output of the system. So the software implementation of the state graph can be understood in different sequence of steps such as implementation and operation, input encoding, output encoding, state codes and state symbol products, application comments for designer and application comments for tester. So what is meant by implementation and operation? So there could be a direct relation between the programs and behavior of a process, sometimes which is described as a state graph. Implementation can be mainly depends on the operations which is need to perform by the states. So operation on the states can be defined like process, repair, like whatever the example you have taken, damage is an operation, format is an operation, repair is an operation, all can be defined. Next, what is meant by input encoding? The name itself tells the giving the input, and encoding is the process of converting the characters into numericals. In some cases there is need to converting the characters into numericals. In that cases, input encoding is the process of converting the given inputs. So what is meant by output encoding? There exist many kinds of output for different transition in finite state machine. So the output can be a single character also, or string of characters, call it subroutines, control transfers. All these roles can be defined as an output encoding. Next one, state codes and state symbol products. So what is meant by state code? So like S, P, Q, R, what are the example we have seen in the hard disk recovery, that is nothing but a state code. Based on the state code, the process will be done. So here we are taking the N states and P different inputs and both stands as 0. If start code, input code are S and I respectively, start code is S and I, input code is I. So this is the pointer value should be taken like start code, different inputs, but process inputs plus input. So I end states plus start state. So this is the way to define the pointer value in the state codes. So next one is application comments for designers. So how can we can make the application comment generally in the implementation way of state table. It has many disadvantages in both the cases. So when control key may change in the future. In the future, if the control key changes, the state also can be changes. The behavior of the internal state and external state also can be changed. When device has most similar but few different control functions, state table has more uses in communication and telephony. So telephony and communications. For example, telephone call. So taking a phone and dialing a call, it is one state, and ringing that call is another state. Picking the receiver side is another state. All can be defined in the. This is a designer should make a thought to make a comment like this application. So this technique can provide fast response time. Response time also will be faster. Next, coming to the application comments for tester, how they will be going to be tested. It is not considered by independent tester. So testers should be dependent on every state to state. They can concentrate on representative state graph or state table. The tester would be concerned only with the bugs in it. So the behavior of this system would help in designing the test case effectively. So this is the way to define the application comments for testers, and by using all this, the software implementation will be done in the state testing. So after completion of this implementation, then the state testing will be performed by going on testing with states, inputs, transitions and outputs. So this is about the state graphs. So this is all about the first topic in the unit 5. So thank you. Hope you all understand about this state graphs. Thank you.